molar heat of displacement is the enthalpy change that occurs when 1 mole of a substance is displaced from a solution of its ions. We want to look at a kind of experiment that will lead to how to draw the displacement curves and how we can use those curves or graphs, and how we can use the graphs to calculate some questions from the plotted values. Well, so we have example what can help us to perform the graphical questions under molar heat of displacement. Procedure. This is a practical example. You are provided with 0.4 molar copper 2 sulfate. Put 50 cubic centimeters of the solution into the plastic cup provided, into the plastic beaker provided. Measure the temperature of this solution at intervals of half a minute for about for 2 minutes, and fill in the table. Fill in the table below. After 2.5 minutes, add solid Q provided while stirring, and continue taking the temperature while stirring and continue taking the temperature up to 7th minute. So this is the table that we have with the results. There is time in minutes, then there is temperature in degrees Celsius. So it is the table that you want to use to calculate and draw the graph. So these are the columns. Six, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we'll have 0 minute, a half, 1, 1.5, 2, 2.5. There's addition at 2.5, so that is marked with an X. Then we have 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5, and 7. So at 0, the temperature is taken and recorded as 16.0. We have to follow that. The 1 decimal place has to be maintained. 16.0, constant 16.0, 16.0, up to the addition, because we still have same reagent. Thereafter, it breaks to 32.0. That 0.0 has to be maintained. After that, there is a drop to 30.0, 28.0, 26.0, 24.0, then we have 21.0, 20.0, 18.0, back to 16.0 where it started at 8. Now questions. Draw a graph of temperature against time. Part A. Graph of temperature against time. So that means we'll have temperature in the y-axis and time in the x-axis. Then kindly note that at 2.5 there is a no recording, because at that temperature there is addition of a given substance as the experiment continues. So the graph has x-axis and y-axis. That is what we want to draw. Then we continue and plot. After plotting, we will come up with a good curve, or simply a graph, and the general graph that we are going to draw from this is what will be used under any displacement. So we have the x-axis and y-axis. So let us have that line as our x. The first axis, that is the y-axis, up to that point. Then we can have x-axis. So that is x-axis, and that is y-axis. The y-axis is up to 30, so we can approximately use 5. So that is 5.0. That is 10.0. That is 15.0. 20.0, 25.0. Then we have 30, 35.0. Y-axis. Then x-axis, we can just have a time interval of 1. So that is 1, 2, 3, 4, 5, 6, then we'll have 7. That is good to show us the kind of graph that we are going to have. So the first plotting is 0, 16. So there is 0, 16. Then there is a half, 16. Then there is a 116 up to 2. 1.5 with 16. And then we have 2. Then there is a break. So let's join the 3, the points that you already have, with a straight line. Good. Thereafter, there is a 2.5 that is giving us a break. 3 is up to 32, the highest temperature so far. So 3, this is 30, 31, 32. Then we have 3.5, 30. So that is 30. We have 4, 28. 4 coming up with 28. 4.5, 26. Then we'll have 5 at 24. 5.5 giving 21. 6. 6 with a plot of 20. Then we'll have 6.5 with 18, and that continues. So we can also join the possible points with a straight line. So if they are plotted accurately, this is the kind of graph we are going to obtain. Now, how do we complete our graph? So there is that to 2.5. Then there is a broken line up to that point. This gives delta H. Not delta H, but delta T, which is the highest temperature minus the initial temperature. Well, so this is the graph for the displacement of copper 2 ions using solid Q. As you can see, there is time in minutes, that is in the x-axis, and temperature in degrees Celsius, y-axis. Let us come up with some questions that we can solve graphically to help us know the enthalpy of displacement. And we are using substance Q to displace the copper 2 ions from the solution. So next question, that is part B. From your graph, or from the graph, determine the temperature change so that is the highest possible temperature. Let us check and know the highest possible temperature. When that is well joined, will be above that 34, above that 32. But according to our graph, we have the highest as 32 degrees Celsius minus the lowest 16, giving us 16.0 degrees Celsius. Part C, calculate the number of moles of copper 2 ions